This video will explain how to graph sinusodial functions. I chose to graph the tides of the waves in Corolla, North Carolina, specifically the Currituck Lighthouse. I got my data points from a reliable source, and I converted the times to hours since 12 a.m. on October 14th. I converted the minutes to roughly what it would be about in decimal points, and then I just put in the height of the water at each time. And I got this function right here. I got the regression function. And then I rounded to 3 decimal places to get roughly about this graph right here, which is about the same. And the purple dots are my points that I put in. So now I am ready to graph this. So my function was 2.478 sine to the 0.496x minus 0.656 plus 2.25. And I sketched a graph, which is shown below. To sketch this graph, I had to pick out individual points of my function. So, for instance, the 2.478 is going to be my amplitude, which is just the height of the graph above and below the midline. Also, I knew from my function that my period was going to be my b value as a divisor of 2 pi. So when I put 0.496 as a divisor of 2 pi, I got that my period was roughly about 12.668, which is about 12 hours and 40 minutes. So that was my graph there. One period is shown right here. And then I also looked at my vertical shift because I know that my d value, which is a vertical shift right here, is going to be my midline of my graph. So from picking out these key points, I can graph and just continue to extend the graph multiple periods. I could also do this if I hadn't seen this graph at all. I could look at this already drawn out graph and I could pick out the key features and determine my function. So first I can see that the midline is roughly at 2.25, as that's the middle of the graph. And then I can also see that one period extends from here all the way to here, because when you look at it's one complete cycle of one high tide in this case and one low tide. And I can see that that was about 12.668. And if I was just trying to write this, I could divide that. I could figure out that what was that divided by 2 pi. And then I can also see my minimum and maximums. The minimums occur at negative 0.23 feet every 12 hours and 40 minutes. So the period. And they're along here. And then there's also the maximums, which occur at 4.725 feet every 12 hours and 40 minutes as well. And then I can see that my amplitude is going to be at 2.47 feet. So I can automatically see that what is going to go in front of the sine is going to be 2.478. So with all of these key features, I can write my sine function if I didn't have it already. Using the key features is very important to determine the function of a graph if you don't have that already written out function. In my case, I did have it, so I just graphed based on my graph that I had on Desmos. But I can also look and put these key features into context based on the graphs of the high and low tides, because in the real world, you have to be able to take these functions and translate them into what they actually mean as in a real world application. So I discovered that the midline is 2.25 feet, and that's going to be the water level of the ocean directly in between high and low tides. The amplitude is 2.478 feet, and it is how much the water level changes from its min or max to the midline, or where the water is between tides. If you double the amplitude, you would see how much the water level changed between tides as a whole. And then the period is 12.668, and it is how long it takes for one cycle of one high tide and one low tide to be completed. 12.668 is roughly around 12 hours and 40 minutes. So it takes 12 hours and 40 minutes to complete one high tide and one low tide. So the minimum occurs at negative 0.23 feet, approximately every 12 hours and 40 minutes. This means that for every low tide, the water level goes down to negative 0.23 feet below the average low water mark. And since this was a regression, it's not going to be exactly exact. So in a real-world application, the tide and the water levels are going to fluctuate a little bit more than what is shown on this graph. So it could be the low tide watermark could be at a positive, or it could be as a negative, as shown here. So the maximum is at 4.72 feet, approximately every 12 hours and 40 minutes. This means that for every high tide, the water level will be 4.72 feet above its low water mark. So using these key features, I can discover what this actually means in the real world and put this graph into context. Using my key features, I can graph and then determine what this all actually means. Using these signed key features of the graph, I can accurately determine what my graph is going to be like and then sketch a rough graph of it. So some key points to take away from here. So you need to use the amplitude, period, phase shift, and vertical shift to graph a sinusoidal function. Underlined in pink is the amplitude. Underlined in yellow is the period, and that is the divisor of 2 pi. It's the absolute value of that. So even if it's negative, it's still just the absolute value of that. And then right here is going to be your phase shift, and box in green is going to be your midline. It's also your D value, or vertical shift. So key concept number 2, you can look at the graph and identify the period, midline, amplitude, and minimum and maximum so you can effectively write your graph. On some graphs, you can also determine your phase shift as well. Then this one was not as easy because it's not a very whole number. It's one that doesn't really apply to this graph. So as you can see, the period, the midline, the maximum, the minimum, and the amplitude. And you can use these to write your function. Lastly, you can put your key features into context and just look at how the graph is labeled and the axes and determine what makes the most sense for each one. So for this graph, my y-axis was labeled as the water level in feet, and my x-axis was labeled the time since 12 a.m. on October 14th in hours. And based on that, I can determine what these key features mean and what they mean in context. And this is very essential because in the real world, you have to look at these graphs and determine what the functions and their key features mean so you can figure out the problems.